Recommendation systems. So recommendation engines are the subclass of machine learnings which generally deals with ranking or rating products or users. Okay, so loosely defined as a recommender system is a system which predicts the uh, ratings a user. Okay, predicts rating of a user might give to a specific item, and these prediction will be ranked and returned back to the user. Okay, so there are various companies which will be using a recommendation system. So Google, Instagram, Spotify, Amazon, Reddit, Netflix, etc. So often to increase the engagement of the users and the platform. Okay. So for example, Spotify would recommend songs similar to the ones you repeatedly listen or liked, so that you can continue using their platform to listen their music. Okay. Amazon uses recommendation to suggest products to various users based on the data how they have collected for the user. Okay, and recommended system are often seen as a black box. So a model created by these large companies are not very easily uh, interpretable. So the result which are like generated are often recommendations of the user that they need and uh, want but are unaware that they need. Okay, so the recommendations are like that, the user that they need and they want which and the products which they want, but they are unaware that they are need. So recommendation system want it until they have been recommended to them. Okay, so that's how, based on few recommendations seeing repeatedly, you feel that you need those product, or probably you are searching, you are in a dilemma for looking out for a product which is going to help you, which you might not even be sure whether such product exists also. Even those are the scenarios which you can come across. So there are different ways to build recommender systems. So some use algorithms, some use formulaic approach, like a page rank, while others use like modeling centric approach, collaborative filters, content based, and link predictions, etc. So all these are good approach, can vary its complexity. Okay, so the complexity does not translate to a good performance. Okay, so good performance again varies with respect to complexity. Some models might be very complex, but their performance might not be that well also. So again, complexity does not mean that it will be giving you a good performance, but ultimately all the approaches will vary based on its complexity. So often simple solution and implementation yields a stronger result. For example, like large companies like for example Reddit or Hacker News and even Google has used simple formulaic implementation of recommendation engines to promote content on their platform. Okay, so here we'll be seeing what the institution of overview of recommended system, and also a bit insights about the implementation, and mainly we'll be seeing where exactly it can be it can be used with respect to machine learning algorithms also. So we'll see a few of the insights of that too. So what defines a good recommendation, like a recommendation engine or a recommendation system? Okay, uh, identifying what defines a good system is the problem in itself, so that many companies struggle with. So again, you are not sure how good your recommendation system is, so maybe it can be better or not, or maybe you will end up worsening the performance by making few changes. Okay, so the definition of good recommendation system helps to evaluate the performance of the recommender you built. The quality of recommendations can be assessed through various statistics that measures coverage and accuracy. Okay, so accuracy is the fraction of correct recommendations out of total possible recommendation, while coverage measures. Okay, so that's the definition which I'm reading. So accuracy is the fraction of correct recommendation out of total possible recommendations, while coverage measures the fraction of objects in the search of space the system is able to provide recommendations for. So this method of evaluation of recommendations is solely dependent on the data set and approach used to generate the recommendation. Okay, so recommender system share several conceptual similarities with classification and regression modeling problems. Okay, so that is why it is an ideal, like as mentioned, several similarities with classification and regression modeling problems. So in an ideal situation, we would want to see how real users react to recommendations and rank the metrics around the user. So basically, whether they are liking the recommendation, or also you can take feedbacks from user whether some things are irrelevant to be recommended to them. So this helps us to improve the recommendations or and the recommendation system. So however, there is a quite difficult, this is not easy to accomplish. It is quite difficult, and like common statistical measures can be evaluate the accuracy of the recommender. So basically here we'll be seeing k-fold cross validations. So basically here like we have already come across with respect to cross validations and k-fold cross validation. So again, this we can use statistically with respect to measuring how good the recommendation system is. So imagine we have built in model which will predict how well the user will rate an item based on the set of features. Okay, so k-fold cross validations can be used to infer the results of the model through accuracy metrics. Okay, so same idea as like train test split, except that we create k many random assigned to training set and test sets. So each individual training set or fold is used to train the recommendation system independently, and then measure the accuracy of the resultant system against the test sets. Okay, so that's the test set, or you can also call them as validation set. So we take the average accuracy to see how well the recommendation system is learning. Okay, so this method is beneficial to prevent your model from especially overfitting. Okay, so you never want your model to be overfitting or underfitting. So in such cross validation would be will prevent us, which will be beneficial to avoid the overfitting. However, again, it is a computationally extensive process. Okay, so definitely it is like computationally time consuming, and also like little manual efforts also. And the second approach would be using a mean absolute error. So here we'll just calculate the mean absolute error by using the prediction and the true value, seeing the difference between them. Okay, so the summation of predicted minus the true value divided by the number of total data points, the same formula which you had already seen. So we can use that. So basically using mean absolute error, this will actually represent the average absolute value of each error in the prediction. Okay, with respect to the rating predictions. And again, lower the mean absolute error, the better the system is performing. Okay, and last one is root mean square deviation. An extension concept of our mean absolute error. So basically here with respect to deviation, so mean square deviation. So here we will be just getting with respect to different variables, and we'll be getting the square of the difference. Again, this summation of squares of the difference between the number of non-missing date, number of actual observations and the estimation time series, which will be squared, and then we'll be using the root. Okay, so I hope you can just go back and refresh with respect to formula if you are not able to get what exactly I meant. So just applying the formula. So basically what we'll be getting is like a similar metric to MEE, but has a strong penalty for which the prediction is very far from the true value, and like if at all the predicted value is very far, then definitely a stronger penalty, and weaker penalty for when the prediction is closer to the true value. Okay, so you always need your prediction value to be truer values, right? And taking the square of the difference. Okay, so taking the square of the difference and predict the values instead of sum of the absolute values. Okay, so this ensures the resultant values is always positive and is larger than when the difference is high, and smaller when the difference is low. Okay, so that's how it calculates. Okay, instead of taking absolute value. Again, similar to mean absolute error, the lower the RMSD, so root mean square deviation, the better the performance of the recommender. Okay, So again, these are the metrics often used to evaluate the quality of recommendation system, but they again lack various components. Okay, so having user data associated with recommendation system is essential to know the true quality of the recommendations, right? So without user data, without unknowing of a person, you cannot randomly recommend something and expect it to be useful for the user and also increase the engagement with the platform. Okay, so definitely user data is must. So that's why all companies go ahead and collect your user data to just make sure their recommendation is better, and also use your data for advertisement, which they can monetize. Okay, so again, giving out data is sometimes good itself, because you will ultimately be the gainer, like finding out a product which you are like figuring out, and you were not sure where exactly to find it. Okay, so recommendation systems does a very good job for doing that, and being able to track hit rate of recommendation and engagement to the platform, and responsive, etc. So even this will help us a lot with respect to recommendation systems. So this will provide a clearer viewpoint of recommendation quality, and other components to be aware of is to know when when to change the recommendation, and when the user hasn't interacted with them for an maybe any amount of time, or when the retrain recommendation is based on the newer ratings or interactions for the users from the users. Okay, so we should always pay attention to whether or not these recommendations are limited to the users or to the subsections of the products. Okay, so again, individually we have to see, and how does the recommender deal with novelty, diversity, and selection bias. So that those are also other things which we need to check. So again, often methods like often probability A by B methods are used for testing these. So to keep the track in metrics. So that is about the insights about how good a recommendation system can be. And next we have collaborative filter, which we'll be seeing in the next video.